Alright, second to last of CCNA4, and it's I don't know, it's an interesting CCNA. It is the server side of the networking, monitoring the network, keeping track of the network. How do we do this? Well, we use a few things, and so one of them you guys have probably seen in Packet Tracer or in a real device, and it's called syslog. Anytime you see that annoying like if a link goes down or up or you have a mismatch and you're in the console, syslog is always going. To see that from when we are telnetting or SSH, we say terminal, wait for it, here it comes, terminal, and then we say monitor, terminal monitor, or monitor, actually I think it's monitor terminal. And so then it'll start giving us these syslog messages again. And anytime we see, or most of the time we see logging, it's syslog stuff. Then we have, I don't know, NTP, which is important for these messages because NTP makes sure our times are all right, right? Network time protocol, super easy thing. Most people use Google. Very important for VoIP and that kind of thing, but we can set our devices to make sure they're syncing with the NTP server so that they are giving us log messages right. Then next we have, we're going to explain SMMP operation. You've heard it, you love it, now you're going to find out what it is. Simple network management protocol, awesome. Non-Cisco devices, a lot of them, most of their configuration is done through SMMP, as we will find out on the stuff we can do. It's also good for just telling us when something went down. Then we're going to have NetFlow, and NetFlow is very cool. It allows us to find bandwidth hogs, and I guess if we were an ISP or something, it would allow us to charge people for bandwidth. We're going to kind of talk about NetFlow. So here we go. So introducing syslog. Okay, so what this is saying is we have seen syslog, but not in this sense. What they're talking about is setting up a syslog server. Alright, there it is. So syslog server, and so whenever anything happens, these send syslog messages. So you say, but what is a syslog message? And so we find out. Syslog operations. So by default, it's on the console line. We have to turn it on the terminal line. Remember, the terminal lines are the VTYs. It buffers inside a RAM. If we do show log, that's what we're seeing. Syslog server, it's going to save it to a server so that we don't use so much in RAM. So we have different levels. We have emergency, system unusable, right? Level 0. Alert, level 1. Critical, level 2. Error, level 3. Warning, level 4. This is probably the one you see the most. Notification, level 5. Informal, 6. Debugging, 7. That's what we see when we turn on debugging, is debugging. It has all this stuff. It has a sequence number, right? Timestamp, facility, severity. That's going to be the actual level. Notice 0 to 7, right? 7 being not important, 0 being that device is done. This text screen, this is usually like what's happening, or no, this is the device, and then what's happening, or maybe it's the protocol, but I'll take a look here. So maybe you guys have probably seen this, right? We have timestamp 00046, link 3, the 3. Okay, so this is our severity. This is our facility, I guess, right? And then we have our metanomic. It says interface point channel 01. And then what happened? This is the description. Changed to up. Okay, so this is what you guys have been seeing in Packet Tracer when it thinks you're consoled in. Otherwise, you can't, like if you're in a physical device and you're telnet or SSH, like I said, you have to do terminal monitor to see this. Oops, to see this logging. So let's see, where were we? Alright. Service timestamp. How's it get it? Well, it'll build one no matter what, but if we want it to, we run the service timestamp log uptime, right? We could set it that way, or we can do NTP server and the address. All right, that's about it. This is actually only a command you need, and so that's where we're actually running. We want them all to be the same, and so in this set state, they ran the service timestamp log on this guy. As you can see, NTP master 1 on here, so it is a NTP server. So then this guy runs to there. Like I said, most people probably just go 8.8.4.4, which is Google. But who knows, if you're in a secure environment, maybe you can't let that time in there. So this is a syslog server. As you guys can see, it's Kiwi server, 30-day trial from SolarWinds. Go ahead, if you have any interest, go ahead and download that, and all you have to do, go in the classroom and issue some commands and power down an interface or something like that, and it'll start mapping this, right? And it just gives you the same thing that you see along your screen, except it's saved to here for when we have a problem. So if you say, like, you have a user say, hey, at 3:30 I lost all internet, you could see, well, is that on our side, is it on the ISP side, what's going on? Another way to see the syslog is to say show logging, okay? And maybe you guys remember with ACLs as well, on the end of an ACL, we could say, like, we could do the oxymoron of, because it's already in there, it has an implicit deny, so we'd say, like, deny IP any, right, for an extended, and then after that say log, and it would show up in this logging syslog file too. So we could actually send all that to our syslog servers. That would show everything that was denied being logged, or we could show everything that would be permitted, but we're going to use a lot of space doing that, but that's fine to do. So if we want to set for a special severity on our server, first thing we do is we say logging and the IP address. That one's simple enough. Then logging trap. So a trap it's going to send us a warning whenever it hits a severity level of 4. Okay. We can also say where to send it from, but what the 4 is going to do is it's going to limit the messages from 0 to 4. So it's only going to send those ones, and those aren't going to be, I don't know, it doesn't really make sense though. Limit the messages levels to 4 and lower. Yep, that's right. So it wouldn't send it when, I don't know, our router blew up and we got an emergency. So, or it overheated, it would probably be an emergency. Okay, how do we verify? Show logging, show logging, show logging. We can actually do the pipe command there, right, and do begin if you wanted to. Do this pack tracer if you feel like setting up NTP and syslog. But we're moving on to SMMP, which is a little more complex. Okay, so SMMP is made up of 3 things, and so it has get and set, right? So get is just requesting information, and it's sent back, and then set is actually, that's how we could actually put IP addresses and all kinds of things on network devices through SMMP if we have it set to write. There's 2 types. We do read only, where it's just going to get information, but then if we allow it to write, then we can actually change IP addresses. And there's actually 3 versions of SMMP, and that's probably the next most important thing. But we have an agent, right? So this is an SMP agent, is one of our network devices, right? So both of these, as you can see, all of these are an agent. And then we have a manager, and then inside of the manager keeps the MIB, okay? And the MIB is a database of SMMP information, and I think it goes over that right here. SMP agents that reside on a managed device collect and store information about the device and its operation. This information is stored by the agent locally in the MIB. The SMP manager uses the SMP agent to access information in the MIB. Wait, so what does it say? Just a second here. Sorry about that. What was I saying? Oh, I was trying to. Okay, so. I don't know what I was trying to say here. This information is stored by the agent. Okay, so that's what I messed up. I told you that the manager had the MIB, but the MIB is actually on the agent, and the manager accesses the MIB from the agent. Okay, so things you can do with the MIB. This is getting information. Set the MIB. That's actually where we actually put information into the MIB, which will then put it onto the agent, such as turn interface off, turn it on, change an IP address, stuff like that. And that's what it's showing here. It's using SMP get to find out if the interface is up. So this is another form of management that we can use. Here's our operations. I think they mostly make sense, except we did trap. We kind of talked about with the last one. So remember trap. This is when it SMMP just runs. It's on a timer, right? So it's just sending it randomly. So if we want to know when something goes down, we set a trap for that, so it'll actually send that to us as it happens. So that's the only other thing you need to know. So now here's the most important part about SMMP. And we have different versions. And basically, if you guys look, version 1, it's bad. Here's why. No encryption, right? Once again. Version 2, no encryption. So we definitely don't want to we don't want to have, say, probably never want to run. We might get away with running SMP version 2 with read-only. So it's just giving us information. That's probably okay. But if we're in a secure environment, we want to run SMP version 3. And the reason why is if we look at this, we have authentication and encryption. Right? We can actually use a username, we can use hashing, and then we actually have encryption if we want to. As you guys can see, we can use DS, AES, 3DS, the stuff we've been seeing for encryption. And that's definitely, like, if we're issuing passwords or something like that, doing set commands, I would definitely have it encrypted and as secure as possible. But that's what you guys, and so we need to look back at this again. So community string, this is just a line. We just do a line. At the end we say write and read, or read only, or something like that. Right? And that's what we do for both 1 and 2, versions 1 and 2. Where it changes with version 3 is we can use a username, or we can start using a hash to authenticate. And let's see, what's it? My customer called and their web server is really slow. Oh, okay. What's going on? He needs read only. So this, at the end of our string, this will make more sense. We have read only provides access to the variables. Write provides read and write access. So that's the set commands. And I don't know, this is, if you guys are interested in I don't know what to really tell you about this. So this is how the MIB database works. It's not really important, nor am I an expert on it, so I'm not even going to try to explain it. This is just showing that we can get resources from our SMP logging to, we could pinpoint when high usage is, or stuff that uses SMP, switch mapping, a lot of logging, a lot of monitoring tools like from SolarWinds, their advanced stuff. If you guys have ever heard of Spiceworks can monitor all your devices on your network and send you emails, and it runs SMMP as well, and just stuff like that. Apparently, what is this? The SMP Navigator website allows the network administrator to research details about a particular OID. Anyways, this is past CCNA or where you guys are at. Just if you can set up some logging, that's what we're going to. We want to know how SMMP works, and so now we're getting to configuring it. Okay, so remember I said read only, write only. So if we're doing a lower level, right? Say SMMP server community string, all right, and where the string right here is, we could put LCSE. We could put, I don't know, John Chambers. You could put, that's what you want. This is what is going to have to match on all devices. And then when we put read only, gives us read only options. So that's the only thing we have to have. This is for logging, right? We could say where our server's at. We could say who the contact is. We could deny. So this, we could set an ACL so that only this guy could access it. And then we can specify who receives the traps, right? Okay. We can enable traps. The notification type similar to what we saw in syslog. Alright, so those are our steps, but it's a little more complicated when we go to 3, but basically all we really need is, this is a good idea, the ACL, but the community, SMP server community, here's the string name, they named it Battlenog or something, then RO, so it's read only, and then they put the SMP ACL, which if we look down here, they named SMP ACL to permit 192.168.1.3, this guy right here. Okay, so the rest of it, it's not really important. Like, not a single part of that is important besides top. It would start working otherwise, but the rest of it is just to secure and to be more specific. How do we verify SMMP? Alright, so once again, same deal, and we're seeing QE syslog, and so the same syslog server has SMP traps that can listen for it, or we can get an SMP, a device that just does SMMP. Can't really see it in my picture, but it's showing similar things to our syslog, except from the SMMP, and like we can do with this, we could monitor processors and all that stuff depending on the program we're using. And so show SMMP is going to show us stuff like this. If we saw a legal operation for community name supplied, that means that somebody's trying to write to us, that'd be bad. Just stuff like that. They're not going to ask you much on this, I don't think. Show SMP community, shows this kind of stuff. Basically, when you use the community string, you don't have very many problems. SMP version 3 is more likely to have problems, okay? And so that's what it's saying right here. SMP version 3 is recommended because it provides security authentication encryption. There are a number of other global configuration mode commands that a network administrator can implement to take advantage of the authentication, encryption, and support. So we can create groups, we can create the username with the group name then, version 3, encrypted. Those are all of our options. As this says, SMP SMMP version 3 is out of the scope of the CCNA curriculum. If you guys are saying, what is Don talking about? There you go. Try configuring SMMP, it's right there. So now we have NetFlow. Alright, so the other stuff was like monitoring what's going on with your device, and it was kind of monitoring processes, but it's not monitoring connections and bandwidth and that kind of thing. So NetFlow, we can monitor what's coming in and outside of an interface. Kind of like, you know, how an ACL, we can write an ACL for this direction, we can write an ACL for the other direction, right? So we can write one this way. We can analyze traffic coming in and out. We can find our bandwidth hogs, and we can do stuff like that. And actually, we can monitor it if we don't have logging on it. SolarWinds makes some free NetFlow analyzer that's pretty cool. So we are on NetFlow version 9, and so now let's get into NetFlow. What NetFlow can do is it's measuring who is using what resources for what purpose, accounting and charging back according to resource utilization. So if we were like an ISP, or if we were a company that just says, hey, you're a bandwidth hog, we have to pay for more for internet, so your department needs to put this much budget in for what they're using, that would be another reason for NetFlow. Using the measured information to do a more effective network planning so that resource allocation and deployment is well aligned with customer requirements. Sure. Using information to better structure and customize a set of available applications and services to meet the user's needs. Well, basically what it's saying is NetFlow can see how intense applications working together are on devices. When Cisco set out to create NetFlow, 2 criteria is provided the guidance and creation. NetFlow should be completely transparent to the application devices in the network. NetFlow should not have to be supported and running on all devices in the network to function, right? So we can set it on one device if we want to. And that. Anyhow, let's see what we were saying. Sorry. Although NetFlow is simple to implement and transparent to the network, it does consume additional memory on the Cisco device, right? So the CPU and stuff is going to be used because it's still processing information. NetFlow stores a record in the cache on the device. The default size of the cache varies based on the platform. Administrators can adjust that. That's why we like to export. So NetFlow you can set up based on source IP address, destination, source port, destination port. We can see the layer 3 information, the type of service, and the input logical interface. Great. Compare SMP to NetFlow. Well, NetFlow is more for bandwidth. So it's pretty easy to set up. Easy configuration. Just like these other ones, like remember SMP, the bare minimum, just put on a community string and an ACL. So now we have interface G01, and so we can track the flow in and out. That's what this is saying. IP flow ingress, that means traffic coming in. IP flow egress, traffic coming out. We could pick one or the other, or we can do both of them like they did. Then we go back out and we say IP flow export to the destination 192.168.1.3.255, and then we tell it to export the version of NetFlow that our program supports. And so I guess they are supporting version 5 right now. And that's how you set that up. Almost all routers support NetFlow, and then what they're saying here is with 3560s we're getting into multi-layer switches, so multi-layer switches do support NetFlow. Verifying NetFlow, show IP cache flow, send it to the server, you're good to go. So that's what we're seeing right there. Another way to check it is on the actual server. And I don't know, none of that stuff's important to you guys, but there we go. Show IP flow export. Make sure you have the right server and the right address up. Other things that probably block it is ACLs. Make sure you're allowing the port of like when you set up your server application, it gives you a port number to allow. I don't know, that's probably about the only place I've had a problem with NetFlow before. Alright, so NetFlow collectors. These are these applications I was talking about. So a NetFlow collector does something like this, and it'll break it into a chart. SolarWinds, I think, it's the one I have the most experience with. It's the most popular. Like I said, they have one that's decent. It can kind of show you something like this. Not the ones that build databases for long term are more expensive. No, SolarWinds is not free. They're one that just does, if you want to see what's happening right now and just see a chart of what's going on, that one does work fairly well. This is kind of what I said. Make sure you set the right ports. You got the application. You go to a website. It runs the application. You don't care about the application. You're a network guy. You just care about what you're seeing. Feel free to do that. Lab. But that was our admin tools. So syslog are these things we've been seeing, right? SMMP can show us similar things, but then it can show us even more, and it can run with a lot of third-party applications. Gives us a lot of really cool information, stuff like switch map. Switch map will tell you like when the last time your ports were used and that kind of thing. Can save you, like, tell you what ports are heated that you're actually using on a regular basis, which ones aren't, so you don't have to worry about pulling somebody's cable out and then they don't have network connectivity. So that's the kind of things SMP does. Best practice, use SMMP version 3, which is outside the CCNA content. But to set up SMMP, all we need is a community string on both devices and some kind of application picking it up. Then SMMP has an agent. The agent builds this MIB, and the MIB, the manager uses the MIB, which is what the network administrator would use to monitor or change. Then we have NetFlow, and a NetFlow collector is an application that collects information from NetFlow, which tells us people are going to Facebook, and how much bandwidth is being used by YouTube. I don't know, we can collect all kinds of stuff like that. But it's all based around bandwidth. So hopefully that's enough for you guys to understand it. If you have any questions, give me a call. Or actually, don't give me a call. Send me